All right, so here we go. Example number 9. Determine the maximum and minimum in this real life problem. For the given cost function, c of x equals 48,400 plus 600 times x plus x squared. We're going to find the average cost function and use it to find the production level to minimize the average cost. And then find the minimal average cost. So what we're going to do here, what we need to do is recognize what are they asking us to minimize. They're asking us to minimize the average cost. In other words, we're going to find the critical numbers for the average cost, not the cost, the average cost. And we have a specific definition for that. That is known as c of x over x. So we're going to take the total cost function, which is 48,400 plus 600 x plus x squared, and divide it by x. And to minimize this, we need to find the critical number, and then make sure that that's the critical number happens to be a local min, and make sure that local min is the absolute min. So after this, we're going to take the derivative of this to find the critical numbers. Maybe I'll do that in the second line. So let's find the critical numbers of this c of x over x. That means that we're looking for whenever this is equal to 0, or whenever this is going to be undefined. So let's begin. So let's begin by finding the when is this going to equal 0. So let's first find the derivative. Either way, we have to find the derivative. So c of x over x prime is going to be so what we're gonna do here is we're gonna we have two ways to approach this. We can use the quotient rule, or we can just simplify this real quick and then in a different way, and then just take the derivative of that. Either way, it should be fine. So let's just go ahead and do the critical number. Let's just do the quotient rule. So the derivative of this will be quotient rule. All right. So let's go ahead and do that. So for this function, we're going to take the derivative of c of x over x, and using this right here, we're going to take the derivative of that. So the derivative of the first one prime times your bottom function minus the top function. Let's say that continues here, and then times I'm already not liking this, so let's maybe make this even smaller. And then just zoom in here. All right, so that would be plus x squared times the derivative of x. All right, and then we're gonna divide all that by x squared, right? So if we take the derivative of this, we just have to focus on doing the derivative of this part first, which is going to be 600 plus 2x times x minus, and then the 48, 600 plus 600x plus x squared. The derivative of x is 1. So all over x squared. All right, so then what we're going to do is we're going to try to simplify the top now, distribute the x, distribute the negative, and we end up getting 600x plus 2x squared minus 48,600 minus 600x minus x squared all over x squared. And so we can see here that these will combine, and then we can combine, we can probably combine these two as well. So actually those cancel each other out, and so we're left with x squared minus 48,600 all over x squared. All right, so that's our derivative. So if we go back over here, that is the derivative all over x squared. So to find the critical numbers, this is going to happen when this is 0. When this is 0, or whenever this is undefined. Okay, so the only way that this is going to be 0 is whenever the whole thing is 0, right? So this is 0 whenever the numerator is 0. We talked about this before. So whenever the numerator is 0. So take the numerator and set it equal to 0. And that will give you when the whole thing is equal to 0. So that happens by adding 48,600 on both sides of the equation. And that will give us, and then now we can take the square root on both sides of the equation, plus or minus. This will be x equals plus or minus 220. Now it doesn't make sense for us to make a production that is negative 220, so the only solution will be 220. Alright, so for this one, for this critical number, this will happen. This will be undefined whenever the denominator is at 0. So that means whenever x squared is 0. But this will imply that this is going to happen when x equals 0. And we know that that's not a critical number because that will make the original function be undefined. So it's not part of the domain. So this will not work. All right, so we found the critical number. Now we just have to guarantee that this is in fact a minimum an absolute min. So to do that, we're gonna have to create we're gonna check whether this is a local min, and we'll talk about that in a second. So it's 220, and we're gonna check for x equals and then c of x over x prime. We're gonna see what's the value of the derivative at the left side of the critical number and on the right side of the critical number. So let's try 1 and 230. So we'll plug in those into the derivative function. So let's try that over here. So here we go. Copy and paste. There you go. So we're gonna try plugging x equals 1. And I chose 1 because that's an easy value to plug in. So it'll be 1 squared minus 48,600 over 1 squared. That's going to give us a positive number on the denominator, but on the top is going to give us a negative number. So that'll be negative over positive is negative. So this is negative, negative. For x equals 230, this will be 230 squared minus 48,600 and over 230 squared. The bottom part will be positive and the top one will be actually positive. So this will be a positive over positive. So this will be positive, positive, positive. So the original average function here will be decreasing horizontal and then increasing, which means it's a local min. So here we have a location of a local min, right? And what we said if you have in the beginning, right, we talked about in this box, if you have a one critical number only and a relative local extrema, then that local extrema happens to be the global extrema. So in this example, this by that box, by that logic, this is actually the location of a global, right, of an absolute min, right? So there you go, right? So we found the quantity, we found the production level that needs to be produced to have an absolute min, but now we have to actually found what is the minimal average cost. So all we gotta do is take the average function and replace it with x equals 220. So we're gonna plug in in the function. We're gonna plug in the 220. All right, and then just because of the time, I'm gonna once you put it there, you're gonna end up getting something like 28800 over 220, which comes out to be 1040. So the minimal average cost will be $1,040. So the minimal average cost of producing X items is, or in this case 220 items, is $1,040, right? And that will give you the minimum average, right? That's the lowest average cost that you're gonna have in this cost function. All right, so that's the end of this section. So I hope you guys found this helpful. Please let